My name is Satwant Singh. I have the pleasure to introduce the next presenter. So next presentation is on MIPI Beyond Mobile, Industrial Computer on Module, a case study. And the presenter is Nikola Nenadic from pygmyTITAN. Nikola is the founder and CEO of pygmyTITAN. This is a startup company established with the goal to make consumer mobile technology available to embedded product manufacturers in various industries. Before founding pygmyTITAN, Nikola was the CTO in Embedded++, the leading design house in Southeast Europe, specializing in development of customized embedded solutions. Please welcome Nikola.
Thank you, Samet. Hello, everyone. So I will make a presentation of a computer on module product that our team is working on for some time. And when we started working on this concept, we were faced with an issue. An issue was how to explain to people what we are doing. There was no name for the market. So we have to think about how to name the market, and this is what we came with. We name it industrial mobile. It sounds like industrial PC, and that was our idea. Industrial mobile basically covers the non-consumer applications of mobile technologies. And what we feel that there is potential of mobile technology to disrupt a number of existing markets, and also to create some of new ones. And we are talking about the medical, robotics, instrumentation, retail. There are a lot of markets which can benefit from mobile technology. And as we are speaking, people are already doing that. This is what I found after fast search on the internet. There are a lot of applications where people are already using mobile devices to make their own products. There are people that are taking smartphones, people taking smartphones, putting them in the casing, or making an add-on electronics on a smartphone. So you have industries that already recognized the performance benefits of a smartphone technology. So next thing was to try to make an estimation about the market size. So what is the size of the industrial mobile market? And it's a multi-billion-dollar opportunity. On one side, you have existing embedded systems market and existing embedded computing market, where you have a lot of opportunities for mobile. And on the other hand, you have a lot of new emerging markets. And some of those markets also have unique feature that there are applications on them that are mobile first or mobile only. And the question is, why would anybody use mobile technology on those markets? So there are a lot of benefits. And I provided a list of benefits here. So when you switch from the industrial PC or the embedded ARM to the mobile, you are getting a lot of these benefits out of the box. And one of the important things is the mobile technology is pervasive with a lot of installed base today, but also you have a rich mobile software application landscape ecosystem, which is really huge. So going back to that, the smartphone is obviously the most popular invention in human history. And this year we will have close to 2.5 billion installed mobile devices in the world. And it is very interesting when you compare that to television and to telephone, which stands only at 1.6 and 1.2 billion. So smartphone is already very, very widely deployed as technology and people is using it. On the software side, we have close to 2 million different applications on Android Store and Google Store. So we are talking about the huge number of companies, programmers that are dealing with the mobile software. And there is one also important factor. ARM landscape is changing. There is a consolidation in the industry. And in the last 4 or 5 years, a number of suppliers left the mobile market recently. And most of those who left were a kind of suppliers that also supported embedded applications. The ones that I left in the market are pure play mobile, and they're not very fond of supporting embedded applications. And also there is one factor that is important, and that is this proportion between the mobile and the embedded market. Mobile market, consumer mobile, is 60 times larger, which means that the mobile suppliers has much bigger budgets, and it is not easy for the embedded suppliers to run the same race. And what we can expect that the technology gap between consumer mobile SoCs and the SoCs for the embedded industry will widen. And the result of that will be a growing pressure to implement consumer mobile stuff into the industrial applications. So, having all this in mind, what are the key obstacles? First one is pure play mobile suppliers are focused on a small number of customers. They're focused only on a high volume consumer mobile stuff. Embedded systems market or industrial markets are highly fragmented. You have a dozen or big number of different markets with different players of different size, very hard to handle. And mobile components are short-lived. Their lifespan is 3 to 4 years, maybe even less. And industrial customers are expecting their products to be long-lived. At least 5 years, 7 years is the norm. So as a consequence, mobile technology stays inaccessible for embedded companies at this moment. So that's where we see an opportunity. And we took one lesson from the past, and that lesson is connected to the industrial PC. So in the early 90s, technology landscape was similar. There were 18 manufacturers of x86 processors at the time. But with the commercial success of the IBM PC, market consolidated. And you have a situation where basically most of those manufacturers left out, and latest innovations were becoming cheap, and there was a pressure to implement commercial PC technology in industrial applications. And how the industry solved that? I have two examples here. Back in 1992, PC 104 Consortium was founded, and they set up a standard for PC-based computer boards. And in 2005, you have a COM Express standard for the industrial PC boards, which was set up by PICMG Group. And industrial PC is a $3.5 billion market now. Now we are coming to the point how to basically make mobile technology for industrial applications. And here we have a comparison between the consumer products and the industrial products. And you can see that they're pretty different. Different things are expected on these two markets. And the question was how to solve it, how you can solve this. So the same way that the industrial PC industry did it, by having a computer on module form factor, standardized form factor, on which you can pack all the electronics from a smartphone in a single component, single board with an open architecture. By doing that, you are hiding complexity of the smartphone inside that module component. And industrial customers can use it as a single module. And that way, we are solving several issues. One of them is a longevity issue, because if you have a standard for the module, then different modules with different SoCs can stay hardware and software compatible. So if one module is out, you can get the next one, and you can keep production going. Also, with a modular approach, you are reducing risk at the customer. And by enabling customers to use that kind of module, you are basically enabling them to build products on a mainstream mobile technology. And all these things are possible as a consequence of a high level of standardization of interfaces in the smartphones, which is basically something that MIPI has done for the past 12 years. And it is important, and that level of standardization enables this kind of a computer module. So going back to the module, and I will just tell a few words about mobile form factor. So all the main boards, all the electronic boards in the smartphone has more or less the same area. And on all boards, you have high level of integration. Those are low power systems. And as a consequence, mobile computer modules can be made small and can be made low power, because that's a direct product of the technology we are using from a smartphone. The things that you have to solve with the computer on module is heat dissipation, EMC, EMI, and RF shielding. And this is our concept. This is how we did it. So we designed a mobile computer on module standard, and we basically packed the electronics from a smartphone in the total PCB area of 21 centimeter. And we made it very thin. We made it only 5 millimeters thick. The module has integrated heat spreader, EMC, EMI is solved, and it has an RF shielding with this heat spreader. So the next thing is, because computer on module is a standard board, you have to define a pinout. So when we were defining the pinout, we have two factors. First of all, we want to base it on MIPI interfaces, because MIPI interfaces are standard in consumer mobile. And we decided to skip power-hungry legacy PC interfaces as much as we can. So here you have a list of all the interfaces that are implemented in our current module. And you have widely used MIPI mobile interfaces, DSI, CSI, UFS, HSIC. We implemented typical smartphone external interfaces, which you can find on most mobile SoCs. Radio is integrated on the module. You already have baseband on the mobile SoC, and we also implemented the RF circuits on the module. We implemented some of the legacy mobile interfaces like SD card and SDIO. Audio is marked in red because you have several interfaces, and that was a kind of an issue for us, so we had to leave them all. On the high performance side, this is the critical thing. Most of the high performance embedded systems need a kind of a high throughput interface. Speaking about MIPI specification, we have a MIPI Uniport M. Alternatively, you can use a mobile PCI Express, but this is a question mark because this is still in the early phase and we have to wait which standard will prevail. But anyway, we need something for this kind of a module. We also decided to implement a number of traditional old-style embedded interfaces like UART SPIs, ASCII-RC, GPIOs. And we have some auxiliary interfaces. So this is how the block diagram of that system based on the mobile computer module looks like. So you have a computer module here, and on the module you have mobile SoC with the baseband RF, DRAM, flash memory, power management integrated circuit with the battery charger, RFICs, front-end modules, and sensors. All of these components are packed into the module. So when you put the module in the system, you connect the battery, power supply, buttons, LEDs as SIM card. On the other side, antennas can be connected directly, as well as the camera, displays, UFS storage, SD card, HDMI, and all other interfaces. And we have a set of embedded interfaces for the built-in embedded function. And this embedded function depends on the use case of a product that somebody that uses this kind of model will need. And this is a table when we are comparing industrial mobile and the industrial PC form factor. Industrial PC form factor is something you can easily find these days, and it's a big market. So from the CPU architecture, industrial PC is based on x86, mobile is dominantly ARM. Board size is like 4 times smaller. Power consumption is at least 2 times, but if you need more powerful PC, it's even more than that. It's up to 10 times smaller. Industrial mobile or mobile SoCs has integrated radio. In the case of the PC, you need to have a radio board. You have integrated battery power management. On the software side, industrial models are based on the Android and Linux. On the PC side, it's mostly Windows and Linux combination. And interesting, the total system price is low because price of the mobile chipset is compared to the PC is lower. And also you have a lot of things integrated, and you need a smaller heat sink, and the total price of the system can be lower when you compare it to the industrial PC solution. So there are several considerations regarding the mechanical and thermal issues for the model. So first of all, you need a suitable connector. And if you want to have all these interfaces implemented, connector needs to have between 250 and 400 signal pins. And it needs to have high bandwidth because if you are using high performance MIPI interfaces, you need a high bandwidth connector in order to have a range on the board. So you can see here how we solve it. We use one of the interposer type of connectors which has 12.5 gigahertz bandwidth, and enables easy module replacement and easy device upgrade. So it's easy to make a module, relatively easy, but the question is, what about the ecosystem? You need more than module, you need other components. So that ecosystem do not exist at the moment. And so the best thing you can do, you can take idea and components directly from the mobile industry with minimal changes. And that's how our concept works. So if you are taking electronics from the mobile phone, then take camera from the mobile phone, take display from the mobile phone, take rest of the components from the mobile phone. And if you do it like that, then technology transfer is easy, and then people that are using this computer on module can have a benefit of taking mobile technology from the source. And also, this is scalable, so they can also take all the future developments of the mobile. But one important thing also, you need to have a unified software architecture in order for all these modules to be also software compatible. So this is a diagram about the mobile software operating system when the situation is pretty clear. Android is obviously dominant operating system. And our idea was to make a kind of embedded Android variant, which is needed to enable customers to fully utilize this kind of mobile platform, because not every customer has Linux expertise or driver development expertise, so they need an easy way to control the hardware. So that embedded Android can be made part of Android open source project or an extension in the form of the middleware. But the important thing is to have the plug and play functionality and to have unified API for accessing hardware. And also, one of the really important factors is security, because when you have a mobile devices, they will use public networks. And if they're mobile, by the definition, you need a strong security architecture in order to be able to communicate with those products. So security architecture should be integral part of the computer on module specification for the mobile. So what are conclusions here? Such open architecture computer on module standard can facilitate usage of the mainstream consumer mobile technology in various industries, can help to do it. For many industries, for many applications, mobile is enabling applications. And we feel that the mobile industry is positioned well to capture this market, both existing and the new markets. And this lesson from the past said that PICMG led the effort for the industrial PC. And speaking about something that can be done, MIPI can take an effort for the industrial mobile computer on module standardization, where basically if you have an open standard, then the usage and facilitation of the technology will be much bigger. So basically, that's it. You can visit our booth and see how the model format looks like. And that's it for me. If you have any questions, please ask. Thank you.
I have one question for you.
Yes?
Have you seen any early interaction or customer feedback on the reception of such a standard?
We have quite a good customer feedback because we are a startup and we are also we were trying to communicate with the customers very widely, and the figures are actually very good. So we were in contact with 250 customers, and 76 of them expressed interest. And we are in an early phase with our prototyping, and we already have 20 EVMs ordered. And those customers come from various industries. Most of them are coming from drone industry. We have a lot of them from instrumentation, like different kind of handheld instruments for various applications. We have a lot of customers from medical, and the rest are coming from a broad range of different industries. Because the customer pain that you can solve with this module is they are having a smartphone in their pocket, and the smartphone is excellent, and they cannot use that technology for their product because obstacles are too high.
So I saw in one slide that you are still considering whether using MIPI import
Yes.
on Unipo or MPCIe. And I was wondering why are you considering that? And moreover, I noticed that you have UFS which use MPHI and Unipo already. Mm-hmm. So why not using MPHI and Unipo as well there?
The thing is how MPHI Unifort will be supported in the future mobile SoCs. We are not sure. We would like to have it because it will make a platform much more powerful. And we were so happy with the Google Project ARA. But I'm not sure what will be the future of Uniport M in the future mobile SoCs. Because in order to reuse it in our system, We need to have it on the mobile SoC, and also we need the software support for the Uniport M, which I would like to have, but I'm not sure how fast that will happen.
Thank you.
Thank you.
A simple question.
Yes.
Do you also, so in your system, you also use those, because the mobile SoC vendors are limited, just several of them, so you also use the common SoC available on the market?
We are trying to focus on the mainstream consumer smartphone SoCs.
Like the
Qualcomm, like the MediaTek or Samsung,
okay.
Yes. Because there is a reason, with this kind of technology, it is important to stay into the mainstream.
Okay.
So what people are getting by using this computer or module, they're getting all the future things from the mobile. And if you disconnect that link,
then you also need, I guess, a lot of support from these companies.
Yes,
like, for
and
development,
that is
all your IOs and
that what is we are trying to do, because our business model is, on one side we have mobile SoC suppliers we are talking to,
okay.
And on the other side we have a fragmented market with a lot of different customers.
Okay.
But the total figures are high enough
to support
us. Yes. Yes.
Oh, okay.
So that was the way how you can get over this technology gap that you have between mobile and the embedded markets today.
Okay, the benefit of your system over the embedded one is you may have like strong performance.
Stronger performance, yes. In terms of power, in terms of radio, in terms of total price, yes.
Okay.
Yes.
Thank you.
Thank you.
So you mentioned that the industrial PC uses Linux and Windows, but you're focusing primarily on Linux and Android for mobile space. Is that based on feedback that you got from customers?
That was based on the feedback we got from customers, and our idea is, so what we are doing here, we are trying to take the best from the consumer world. And obviously, you have a number of players there. Android is open, so Android it's easy to use. iOS is a candidate, but it is closed. Windows, unfortunately, has a market share of Windows is too low. So there is not enough applications and programmers. That's why we decided to go with Android. Because there is one important thing. We are targeting mobile first and mobile only applications. So we want to be able to, for our customers, to take the applications directly from the smartphone and put them with some changes into their products.
Thanks.
Okay.
Thanks. You also mentioned security.
Yes.
How do you see that playing out in terms of on the hardware side or software?
Okay. On the hardware side, what you need a hardware root of trust, and you need a secure boot mechanism, definitely. So, after that, you can establish the chain of trust in the Android, and it can go up to this middleware, which has an API to access all the hardware. So that is what I can say now, because we are a startup and we don't want to tell everything at this moment. But definitely it is needed, because unlike industrial PC, which is connected to the LAN in most cases, mobile products are on the public networks, which makes a big difference if you're talking about the security issues.
Yeah, and that's an interesting one that, from a MIPI perspective, has been coming up more and more. About is there a role for MIPI to address some security aspects or work with other organizations? Because we, to date, have kind of taken a hands-off approach to that. It's outside of our scope.
That's a very hot topic.
Yeah.
And basically, we need to solve it somehow. So it would be nice if MIPI could address it. Otherwise, manufacturers will have to do it. But that is something that is very, very urgent and very hot topic. Thank you. OK, thank you. Thank you very much. Thank you.